हेलो एवरीवन, मेरा नाम अवनी है एंड वेलकम टू माय यूट्यूब चैनल। हमारा आज का टॉपिक है स्टोरेज स्ट्रैटेजीज विच इज़ अ यूनिट 6 ऑफ DBMS सीरीज विच वी आर डूइंग। अगर आपने इसके पहले की वीडियो नहीं देखे तो आप सीरीज में पीछे जाके बाकी यूनिट के वीडियोस भी देख सकते हैं। So in today's video we will be covering following topics. So these are the three methods as a part of storage strategies we will be covering today. सो फर्स्ट लेट्स स्टार्ट विद इंडेक्सिंग। अब इंडेक्सिंग का मतलब तो आपको ऑलरेडी पता होगा। नॉर्मली कोडिंग में भी इंडेक्सिंग क्या होता है, अगर हमारे पास कोई एरे है 1 2 3 4 5 तो इसके इंडेक्सेस क्या होंगे, इसका 0 होगा, 1 होगा, 2 होगा, 3 होगा एंड 4 होगा। ये बेसिक इंडेक्स का मतलब आपको पता है। नाउ DBMS में इंडेक्सिंग क्या होता है या इंडेक्स का मतलब क्या होता है, लेट्स अंडरस्टैंड दैट। So indexes are special lookup tables that the database search engine can use to speed up the data retrieval. Data retrieve करने के लिए हम एक special lookup tables बनाते हैं by using the indexes. A database index is a data structure that improves the speed of data retrieval operations on a database table, जिससे efficiency बढ़ जाती है हमारी. An index in database is very similar to an index in the back of a book. जैसे बुक अगर हम ओपन करते हैं, हमें किसी पेज पे जाना है या किसी यूनिट 6 पे जाना है मुझे, तो पेज नंबर मुझे पता चल जाएगा उसमें। मैं अगर इंडेक्स में चेक करूंगी पेज नंबर 62 आई हैव टू गो। Indexes are used to retrieve data from the database very fast. The user cannot see the indexes. They are just used to speed up the searches and queries. So indexes as a user point of view से मैं देखूँ तो वो मुझे दिखाई नहीं देंगे। ये प्रोग्रामर point of view से बहुत important है। Updating the table with indexes takes more time than updating a table without, because the indexes also need an update. So only create index on columns that will be frequently searched against. So the syntax usually which will be to create and drop the index will be this. Syntax will be create index, the name of the index which we are giving, on the table name on which you are creating an index, and the column names inside that. Let's see an example. Create index and I'm giving the index name as index student name on student table with student name as a column. Now let's understand syntax to drop an index. Drop index, the name of the table, dot the name of the index which you have created earlier. Let's see an example. Drop index is your syntax, student is your table name, dot index student name. This is the index name which you have created. So this is how we can drop that index also. Dropping the index means deleting that index. Now what is indexing? It is a way to optimize the performance of the database by minimizing the number of disk access required when a query is processed. It is a data structure technique which is used to quickly locate and access the data in a database. For an example, अगर मुझे कोई data search करना है, मुझे roll number 15 का डेटा चाहिए फ्रॉम द स्टूडेंट डेटाबेस, जिसके अंदर अप्रोक्सीमेटली लेट्स से 60 स्टूडेंट्स का डेटा स्टोर्ड है ऑफ डिफरेंट डिविजन्स, राइट? सो बाय यूजिंग इंडेक्सिंग इट बिकम्स वेरी फास्ट फॉर मी टू लोकेट दिस 15 रोल नंबर इन द डेटाबेस। नाउ अब इंडेक्स का स्ट्रक्चर कैसा होता है वो समझते हैं। इंडेक्सेस आर क्रिएटेड यूजिंग फ्यू डेटाबेस कॉलम। फर्स्ट होता है सर्च की एंड सेकंड होता है पॉइंटर। सर्च की जो है वो यूजुअली हमारा प्राइमरी की होता है, यूनिक की होता है, जिसके थ्रू किसी भी डेटा को ढूंढना इजी हो जाता है। अगर एम्प्लॉय टेबल है तो उसमें अगर मैं एम्प्लॉय आईडी से ढूंढूं कोई डेटा तो इट बिकम्स वेरी इजी फॉर मी टू लोकेट दैट डेटा। सिमिलरली अगर स्टूडेंट का डेटा है तो रोल नंबर उसकी प्राइमरी की होगा, डायरेक्टली उसको एक्सेस करना ईजी हो जाएगा। नाउ पॉइंटर इज बेसिकली द ब्लॉक नंबर, एड्रेस जहां पे आपका डेटा स्टोर्ड है। आपका डेटा इस तरह के ब्लॉक्स में स्टोर होगा बैकएंड में, राइट? सो वो उसका एड्रेस लोकेट करेगा कि कहां पे वो स्टोर है। सो पॉइंटर इज नथिंग बट द एड्रेस ऑफ दैट पर्टिकुलर डेटा ब्लॉक. The first column is the search key that contains a copy of the primary key or the candidate key exactly. These values are stored in sorted order so that the corresponding data can be accessed quickly. Usually जो हमारा roll number, employee ID and जो भी primary keys होते हैं वो usually sorted होते हैं. And the second column, which is this, is nothing but a data reference which can contain a set of pointer holding the address of the disk block where that particular key can be found. Now indexing has various attributes. The first one is access type. This refers to the type of access such as value-based search, range access, etc. Access time, it refers to the time needed to find that particular data element or set of element. The insertion time, it refers to the time taken to find the appropriate space and insert a new data. Deletion time will be exactly time taken to find an item and delete it as well as update the index data structure. Space overhead, it refers to the additional space required by the index. I hope these terms are clear. Now let's understand different methods or different types of indexing which we have in DBMS. So there are three types of major indexing: primary, secondary, clustering. The primary further has it dense and sparse. Let's start with the primary indexing first. If the index is created on the primary key of the table, then it is known as primary index. These primary keys are unique to each record, which we already know that. As the primary keys are stored in the sorted order, the performance of the searching operation is quite efficient because it is very easy for me to locate. अगर मुझे कोई roll number 10 ढूंढना है लेकिन उसके पहले 9, 8, 7, 6, 5 stored है and ये proper ascending order में, it's very easy for me to go directly to the 10. So let's take an example. There is a student table with roll number, name, address, city and mobile number as the few columns inside it. So I am creating an index with syntax create index. I am giving the index student roll number on the student table with roll number as the attribute. So this is my index name, this is my table name and this is my attribute name. So the exercise for you that you have to create a primary index for employee table with the employee ID, name, address and city. Now, like I said, the primary index is further divided into dense index and sparse index. Let's understand them one by one. अब dense index क्या होता है? There is an index record for every search key value in the database. मेरा index कुछ ऐसा दिखेगा. We already know that यहाँ पे मेरी key होगी, the search key, and यहाँ पे होगा pointer, right? For an example, if I want to search number 1, 2, 3, 4 and यहाँ पे उसका exact address है and ये मेरा main database है, यहाँ पे 1, 2, 3, 4, 5 and so on data stored है, right? So for 1 it will access over here, it will go over here, it will go over here. So for every record we have an index key over here. It is exactly the replica. So in dense index there is an index record for every search key value, like over here if you see 101, 102, 103. This makes searching faster, but it requires a lot more space to store index records. क्योंकि ये तो हम already store कर ही रहे थे. अब यहाँ पे हम क्या store कर रहे हैं? सारी की सारी primary key store कर रहे हैं and every data block का address भी store कर रहे हैं. जैसे ये हमारे पास एक data है, इसका address भी मैं store कर रही हूँ. So ये मेरे पास extra space occupy हो रहा है. In this, the number of records in the index table is same as the number of records in the main table because exactly यहाँ पे अगर 10 record है, so यहाँ पे भी 10 record है. Index record contains search key value and a pointer to the actual record on the disk. We have understood that यहाँ पे उसका address store होगा of this actual record. Now let's understand sparse index. Index records are not created for every search key. It's like dense, every search key के लिए record नहीं create होता है. The index record appears only for few items in the data file. It requires less space क्योंकि less number of index key generate हो रहे हैं, less maintenance overhead for insertion, deletions, but is slower compared to the dense index for locating the records. क्यों? Because अगर मुझे 101 ढूंढना है तो मैं directly first record में मुझे मिल जाएगा. Then 104 ढूंढना है, then मैं starting से check करूंगी. क्या ये 104 है? क्या ये 104 है? क्या 104 क्या ये है? हाँ है. So it took a little more time to check one by one each of them and then find this one. So time थोड़ा ज़्यादा लगता है but space कम occupy करता है. To search a record in sparse index, we search for a value that is less than or equal to the value in index for which we are looking. After getting the first record, linear search is performed to retrieve the desired record. अगर मैं 104 ढूंढ रही हूँ तो मैंने यहाँ से चालू करूँगी 101 से. If I start looking, I will check 101 is lesser than 104. I might try to find a higher one. 105 is the higher record. Then it will keep on doing the linear search to find 104. In the sparse indexing, as the size of the main table grows, the size of the index table also grows similarly. Now let's understand the secondary indexing, which is also called as multi-level indexing. If I want to try and find record 101, first I will generate this index 101. There will be another multi-level, which is the secondary index. From primary it will go to secondary, and that record will fetch the data from the main table. So to reduce the size of the mapping, another level of indexing is introduced. That's what we understand over here. A huge range for the column is selected initially so that the mapping size of the first level becomes smaller over here. Then each range is further divided into smaller ranges. Like this range could be divided into two parts. This range could be divided into further two parts. The mapping of the first level is stored in the primary memory over here so that the address fetches faster. The mapping of the second level and the actual data are stored in the secondary memory hard disk. Both of these are stored in the hard disk. Now, how to find a particular record? So, if you want to find a record of roll number 112, which is this, then it will search the highest entry which is smaller than or equal to 112. The first level index, what it will get is 101 at this level. Then in the second indexing level, so if we want to find the record roll number 112 of Neeta, then it will search the highest entry which is still smaller than or equal to 112 in the first level index. So what is it going to get? Of course 101 over here at this level. Then in the second index level, again it does the max 112 less than equal to 112, and it will get this 111 over here. So this is the first one, this is the second one. Now using the address 111, it goes to the data block and starts searching each record till it gets 112. So it will start till it searches the record 112. So it will directly find the next value itself is 112. This is how the search is performed in this method. Inserting, updating or deleting is also done in the same manner only. So basically secondary index क्या है कि primary indexing के अलावा एक और level of indexing create होता है secondary indexing over here. Now let's go to the next method, which is clustering. Sometimes the index which is created on non-primary key columns which may not be unique for each record. In this case, to identify the record faster, we will group two or more columns to get the unique value and create the index out of them. This method is called as clustering method. The records which have similar characteristics are grouped and indexes are created for these groups. For an example, here the index is created for the non-key value, जो primary key नहीं है. ऐसा होता है बहुत rare scenarios में that I want to search data on a non-key column. So this is the department over here, CE, EE, EC, ME, right? Now I will search for the similar data and group them together. So the CE has been grouped together, EE has been grouped together, EC has been grouped together, ME has been grouped together. However, it will point to the first one with that group. Again, EE is pointing to the Meera, which is the first one. EC will point to the first one, Ajay, and ME will point to the Nayan, first record in that group. So this is my index table and this is my main table from which it is accessing the record. So it has grouped them first and then found the index of the first one and accordingly it pointed. Let's understand the next one, which is B tree. B tree is also called as balanced tree. Now tree का मतलब आपको already पता होगा. अब tree का structure आपको already पता होगा. कैसा होता है? आपको एक पता है कि एक first node जो होती है वो root node होती है. उसके नीचे जो नोड होती है उसे हम कहते हैं इंटरमीडिएट नोड या फिर लीफ नोड. लेकिन अगर इसके नीचे भी जो है तो ये इंटरमीडिएट नोड बन जाएगी एंड ये लीफ नोड बन जाएगी. अगर मैं इसको ऐसे ही रखूं तो ये एक बैलेंस ट्री नहीं है, लेकिन अगर मैंने यहाँ पे भी दो नोड्स डाल दी तो जाके ये बैलेंस ट्री बन जाती है. सो दिस इज व्हाट इज कॉल्ड एज बैलेंस ट्री. सो वी कैन से दैट बी ट्री इज अ डेटा स्ट्रक्चर दैट स्टोर्स द डेटा इन इट्स नोड इन अ सॉर्टेड ऑर्डर. In a sorted order, we can represent sample B trees as follows. For example, like I told you, there is one root node. Further, there are leaf nodes below that. Just remember this always, that the left hand side is always lesser than the right hand side. Even in this, if you see the keys over here, It's in ascending order always. So B tree stores the data in such a way that each node contains keys in an ascending order. Each of these keys has two references to another two child nodes over here, like we see. The left side child node keys are less than the current keys and the right side child node keys are greater than the current keys. We understand that 11 is the current key, so left hand side is lesser than that and right hand side is greater than that. So suppose we want to search 18 in the above B tree structure. First, we will fetch for the intermediary node, which will direct to the leaf node that can contain a record for 18. So first we'll see this is the root node. We want to search 18. So obviously 18 is greater than 11. So I will go on the right hand side only. So in the intermediary node, we will find a branch between 16 and 20 nodes. Over here further, I will go to leaf node. So then at the end, we will be redirected to the fifth leaf node. Here in DBMS, we will perform sequential search to find the 18. We will start from here and in a sequence, we will start searching and there we will find 18 as a node. Now let's understand the next method, which is nothing but hashing. So for a huge database, it can be almost next to impossible to search all the indexes value through all its level and then reach the destination data block to retrieve the desired data. So hashing is a technique to directly search the location of the desired data which we are looking for in a query on the disk without using the index structure. So यहाँ हम index structure use नहीं करेंगे. Data is stored in a form of a data blocks, we already know that, whose address is generated by applying a hash function in this method. Since there are no indexes, so the address is generated by using a hash function. There are different hash functions, we will see that. In a memory location where these records are stored known as data block, or it can be called as data bucket also. Hashing uses a hash functions with search keys as parameters to generate the address of a data record. Data buckets are the memory location where the records are stored. What is a hash function? It's a function that maps all set of search keys to actual record addresses. Generally, the hash functions uses a primary key to generate the hash index address of the data block. So the type of hashing methods which we have are static and dynamic. We will understand them one by one, but for now, what is hashing? जब बहुत सारा database में data है, so it becomes very difficult and time consuming process कि हम indexing के through search करें. So hashing ऐसी technique है which comes very handy and इसका result बहुत जल्दी fast आता है. ये कैसे होता है? इसमें indexes नहीं होते, इसमें hash function होता है which we will use to generate the address of a particular data block. So there are two types of hashing methods. One is static hashing and another one is dynamic hashing. Let's understand static hashing first. In static hashing, the resultant data bucket means what? The data block address will always remain the same. अब ये कैसे? For an example, if you generate an address for say student ID equals 10 using a hashing function mod 3. Now when you divide 10 by 3, what is the remainder you will get? That is going to be 1. So your resultant bucket address will always be 1. It will not change. So you will not see any change in the bucket. So even if आपका data grow होता है, उसका address is going to be always 1 only. Therefore, in the static hashing method, the number of data buckets in memory always remain constant. They never change. Dynamic में क्या होगा? Any guesses? Exactly इसका opposite. So the drawback of the static hashing is that it does not expand or shrink dynamically as the size of the database grows or shrinks. अगर मेरा डेटा बढ़ रहा है तो उसका साइज भी बढ़ना चाहिए, राइट? अगर मेरा डेटा कम हो रहा है so मेरा डेटा बकेट भी कम होना चाहिए, राइट? So in dynamic hashing, data bucket grows or shrinks, which means added or removed dynamically as the record will increase or decrease. Dynamic hashing is also known as extended hashing, as it can extend. Right? So for an example, in dynamic hashing, the hash function is made to produce a large number of values. For example, there are 3 data records, D1, D2 and D3. The hash function generates 3 address. उसने 3 address generate कर लिए, 0101, 1001 and 1010 respectively. This method of storing considers only part of this address. So for example, initially it will take only first 1 bit to store the data, which is 0 and 1. So it tries to load 3 of them at address of 0 and 1, because in the third one also the first bit is 1 only. So in 0 and 1 में D1, D2, D3 तीनों store करने की कोशिश करेगा. Now D1 is stored in 0, D2 is stored in 1, but where will we store D3 because that is also 1 again. So as we see the problem that no bucket address is remaining for D3, the bucket has to grow dynamically to accommodate D3. So it changes the address have 2 bits rather than 1 bit. So for example, मैं यहाँ 1 bit लेने की जगह 2 bit ले लेती हूँ. यहाँ पे 0 1, 1 0 and let's say 1 1. So if you see over here, D1 went at 0 1, D2 went on 1 0 and D3 went on 1 1. So it changes the address and have 2 bits rather than 1 bit, and then it updates the existing data which have 2 bits address. So जो पहले का record store हुआ था उसने उसको भी update कर दिया, and then it will try to accommodate D3. So this was dynamic hashing. These are some majorly asked questions in exams which you have from this unit. Explain the indexing and the different types of indexes which we have understood today. Explain the B tree and explain the hashing. If you have any doubts or any question, please do mention them in the comment section. I will try to reply as much as I can. Also, please try to complete all the exercise question. If you do that, you will be able to follow along the series very well. अगर आपको वीडियो पसंद आया है so like ज़रूर करना and subscribe my channel and ring the bell icon for the next video. I will see you in Unit 7.